Is it recording? Oh, okay, can already. All right, thank you all for coming for today's lesson. Today we'll be going through June holiday homework 1 answers. Okay, these are the set of the answers or questions that I have already given. So just to go through some of the methods on how to do this kind of question. Okay, give me a minute. That's my... Okay, so for the first one, express the number 99 as a product of its prime factor. So you notice we just need to do prime factorization over here. Divide by the smallest prime factor from 3 onwards until we get in terms of its just the number 1. So this is written as 3 square times 11, not 3 times 3 times 11, but 3 square times 11. Okay, the second type of question, find the smallest integer value of n for which 99n is a multiple of 24. Okay, if 99n is a multiple of 24, okay, multiple of 24, there are a few things to take note. If it's a multiple of 24, it means all the factors of 24 need to be included. Okay, so what are all the factors of 24? So here I did a prime factorization for 24. So 24 divided by 2, 2, 2, and then 3. This is actually 2 cubed times 3. So 24 is 2 cubes times 3, right? When 3 is a multiple of 24, all the factors need to be included into what? Into the number 99 times n. So let's take a look at the method. First method, if I were to include considering only just the factors, okay, look at the factors of 24. This is 2 cubed. Is 2 cubed inside the factors for 99? Don't have, right? So we need to include this inside here. We add on. So what do we multiply? The number that we are missing, the factors that's missing here will be the 2 cubed. Then I check 3. 3 is already included inside 3 square. So this one I don't need to multiply any extra. What about 11? But 11 is not a factor of 24. So we don't need to worry about the factor 11. We just need to look at this factor, which is 2 cubed, which is the number 8. Okay, this one is the first method. Those students who are able to do the prime factorization, you can observe, then you can do it directly. If you cannot do it or you're not very sure whether is your answer correct or not, what you can do is there's a second method, number 2. Now, method number 2, this one, the keyword over here is multiple, right? When we're talking about multiple, then we need to think of LCM. Okay, LCM of what numbers? The numbers that are involved here will be 99 and 24. So we are actually looking at finding the LCM of 99 and 24. Okay, then what is this LCM? How does it help me to find the n? The LCM of 99 and 24 is actually equals to 99 times n. Okay, so first let's find the LCM for 99 and 24. So 24 has 2 cubed. So LCM definitely must have 2 cubed, must involve all the factors. 3 and 3 square, I must choose the one with the higher power. So it will be 3 square. Then 11 include all the factors. So this LCM is equals to the number 99 times n. So if LCM is equals to 99 times n, how am I going to find n? Okay. Then what can we do? We just need to divide away 99 and we can get the value for n. Okay, this type of method can be done if the number is not very, very big. There are some questions the teacher might purposely set it to be the number is very big that your calculator cannot calculate, then you probably need to cancel away by powers, right? If not in N level, the numbers are usually manageable, should be able to find the answers. Okay, with that, I'll move on to question 2. Question 2, given that 5 to power of -2 times 5 power k equals to 1. Now I need to recap a few important ones. A to the power of n, multiplication a to power n. What happens to the powers? The powers add together. Okay, Then a to power of 0, anything to the power of 0 is the number 1. So in this case, we need to use these two concepts over here, right? What we're going to do, this is multiplication, okay? And then this one is 1. You notice this is not of the same base, so we need to change this base, okay? Change to base 5, right? And 1 is 5 to the power of 0. So now all of them are in the same part, all of the same base already. Hello. Okay, all of them are in the same base already. Then we can change this, right? So I have multiplication. Multiplication means the power at each other. So -2 plus, okay, and then equals to the other power 0. Right, what you want to do, you can also write one more step. 5 to the power -2 plus k equals to 5 to the power of 0. Then because of that, they have the same base, so the power are the same. But for me, I just did a shortcut directly to get to the answer. Okay, so need to use these two methods. Why I picked this question, this is a very common question in exam. Now, all these questions in the papers, right, that you have, that I'm given, right, it's not I create, right? It's either I take from TYS, if not, it's from the June papers, right? So it's all examiner standard questions, right? So should not be overly difficult, also not too easy as well, right? Next question, part B. Given that this one over here, I have 7. You notice they are all base 7, but then this one is to the power of roots, right? So we have to know this power. Anything to the power of root, let's say m, a to power n, right? When we have root, it means it's a fraction. The power becomes a fraction. So base is still base a, right? The power is m. Now it says this is the root, right? Root 3, root 2, root whatever number. This is the root. It will change to be divided by the power n. Okay, so if for example, how do I do square root a? Square root a, this will be power 1. This one is square root. So this one will be a to power 1 over 2. These are the more common ones that will be repeated. So in this case, if this is cube root, so this is power 7 to the power 1. The power here is 3. So it's 1 divided by 3. 7 to the power 1 over 3. Okay, then we already know it's 7 to the power n. So n will be equals to 1/3. Okay, any questions over here for this part? Yeah, you notice the questions that we do in class or whichever may be a bit more difficult, but for N-level exam, the normal TYS standard, right, is usually 1 or 2 concepts. It's more straightforward, so still manageable. Don't be too afraid of the question. Okay, next one, simultaneous equation. Maybe I just go through a little bit. We have done something similar before. Okay, for first one, what we are going to do, for me, I try to solve by elimination. There are some students who also do by substitution. Okay, but I can go through the substitution later as well. Okay, but if I were to do elimination first, all right. First one, for me, I will try to make something the same numbers. So in this case, I decided to make the x the same numbers. So I notice this is 4x, this is 2x over here. So what I do, I multiply by 2 throughout the whole equation. Okay, so in case some of you might mistake and then forget to multiply certain numbers. Then next thing, what do we look at? After I multiply, this is 4x with 4x. The sign over here, this is positive 4x. This is also positive 4x. The sign over here, it has the same sign. So when you have the same sign, you subtract. Okay, so when we do subtraction, we have to be very careful because the sign over here can change. Negative times negative will become positive. So this one will be, over here, this portion will be minus 6y subtract negative y. Okay, minus 6y subtract negative y. This one will become negative 5y. And this is negative 46 minus 9 to give you negative 5. Then you get the number 11. Okay, then after that, I sub y into any one of the equation, find the value. Okay, what happens if I do substitution now? When it's this kind of question, if I do substitution, I will always go for the numbers that has little fraction or no coefficient. That means letters that are on their own. You notice this one, y is on its own. So in this case, I will aim to make y the subject from equation 1. Okay, I'll aim to make y the subject, and I will probably shift my y over here and my 9 over, so that y will become positive y. So this will be positive y. This one will be 4x. Positive 9 go over to the other side, become negative 9. So I'll sub y equals to 4x minus 9 into equation number 2, right? Then when you do that, you have 2x minus 3 times of y. For students who do substitution, if you have fractions, okay, the number to multiply, right, only go to the numerator. Do not multiply the denominator with the number also. If not, your answers will all be wrong. So only multiply to the numerator. Okay, so in this case, 2x minus 12x, negative times negative plus 27, negative 23. Then we get negative 10x equals to, this one will be what, 30, 50? 50. Negative 50. So x will be equals to 5. Then you can substitute back into 5y. So y will be equals to 4 times 5 minus 9. 20 minus 9, that will be 11. So the answers will be the same. Okay, so for students who do substitution, if you choose, try not to choose something with that you need to divide and get fractions. If you have, you do into fractions, the number you multiply only goes to the numerator, not the denominator. Okay, only the numerator. All right. Okay. Hi, Letao. Letao, you didn't have a hard copy of the worksheets. You know where to find all the soft copy? Letao. Okay, never mind. I'll just continue. Next page. That's how the soft copy are on Google Classroom. Huh? Okay, next one, question number 4. This one is a real life situation question. Okay, actually the question is actually just very simple for part A. So how much the apple cost, we just take total minus everything. Okay, but the one that comes with the common sense is part B. It looks very difficult, but actually it's just very simple. Now, when we have a total cost of $5.90 to be converted to $6.80 per euro, what does this actually mean? We need to observe our axis. First one, our axis over here, the x-axis over here is in euros, correct? So if this is in euros, what is the data value given to me? The value given to me is $6.80 euros. And then the corresponding cost is $5.90 dollar. So this one is in dollars. So this one is $5.90 in dollar. Okay, wait, give me a minute. Okay, so this one is in dollars. So what we have down here, right? We have one pair of information. The x-axis is euro. So the x-axis is euro. Then the y-axis is in dollars. So from here, we get 1 point. The point is $6.80. Then the dollar is in $5.90. So that's how I get this point. I'll go to look for $6.80. I go all the way up and look for $5.90. And these two values here join up to a point, 1 point over here. Okay, so this point itself, but 1 point itself cannot help me to draw a line, correct? But I must always remember when I start changing money, there is at the initial start, if there is no money, no euro dollar, there is also no dollars, right? So there is always this starting point 0, 0, which we have to use a little bit of common sense to guess it. So if you don't have common sense, maybe you'll be like, what to do with the graph? Okay, but then in that case, so since we have 2 points, now I draw a line to straight line, a conversion graph to change to join up these 2 points, and I get a conversion graph. Okay, but this is purely for estimation. If you do the exact calculation, can give you up to decimal places. But to estimate from the graph itself, you only read based to according to the nearest possible value that you can read from the graph itself. So now the question say, use your graph to estimate. If you were to calculate, all right, if you use your numbers to calculate, you will not get the correct answer. You need to use the graph to calculate the cost of the mineral water. So which one is the mineral water? Mineral water, $1.20. $1.20, that is in dollars. Dollars, $1.20 over here. So we draw one line across and estimate the value. It may not be exactly that number, but that's the nearest possible value that I can get. So this will be $1.40 euro. Okay, different people may have slightly different answers depending on the accuracy of you drawing your graph. For this kind of practical situation question, usually the teacher gives marks based more on the conceptual understanding rather than the actual accuracy of the numbers itself. Right, so this is just a very simple practical situation question. Okay, let me move on to the next question. Now, next one, circle properties. A lot of students will tell me I cannot remember or what are the cannot see. So I make it always a habit for myself. Whenever I want to do circle properties, I always tell myself I need to recall these 5 circle properties, right? If you notice my answers later in future, every time I see a question, I will always draw it out. So it's a good habit for yourself to refresh your memory again and again. Okay, if not, you cannot remember. So first, we need to take a look at the diagram and look for some important things. Now, the question already say A, B, C, D, and E lies on the circle with diameter AC. Diameter means we'll have 90 degrees semicircle. But in this case, my diagram, does it look like there is any semicircle? No, right? They only tell me this is the diameter. So what is the, then they don't give me 90 degrees. Okay, that means that concept where I need to use angles in a semicircle is 90 degrees, this one no need to use. Right? Don't have, I cannot see. Then what did they give me this for? If they give me a diameter like that, what does that mean? That means I also have the radius. So in this case, this one A to a center O, this one will be my radius. All right, why do I need that? Because later they say that is a tangent. So GA is a tangent. Tangent is perpendicular to the radius. So you need to look for tangent and the radius itself, where you know, oh, this is 90 degrees. So first one, we have already used part 1 over here. Tangent is perpendicular to radius. Do we have tangents from external point? Don't have. Okay, next one, let's take a look at C and see the others, right? Angle at center twice angle at circumference doesn't look like it yet, so I do not know whether need it or not, but I think I definitely have 1, 2, 3, 4, the one that looks like a butterfly, angles in the same segment. Okay, if you can see, I have this one over here, 1, 2, 3, and 4. Okay, so the moment I know this, I know, oh, this angle and this angle are equal. This angle vertically opposite, so definitely this one will be 65 degrees. Then I maybe need to find this angle as well a bit later. Okay, do not. Then next thing, what other pictures do I see? So I already have this, right? Angles in opposite segment, again, 4 points, 1, 2, 3, 4. So I check 1, 2, 3, 4, 4 points. Or maybe I can also have B also, B as well, right? It can be, but in this case, I'm just going to focus on this quadrilateral here, because this involves the angles that we want to find. Okay, you want to use B also can. So in that case, angles in opposite segment add up to 180. Where are the opposite angles? 128 with this one over here. So I got this angle. So how do I find this angle? 180 degrees minus 128. That will give me 52 according to my calculations. And that is angles in opposite segment. Okay, then now my question tells me if I have 152, this 152, I got here 65, I can definitely find other values, right? I can find this one over here, okay, AEB. So in that case, let's go through the remaining of the question. Calculate angle GAE. So once I know this angle is 52, this angle will be 90 degrees minus 52. I should put one more. Tangent perpendicular to the radius. Is that okay? Next one, angle AEB. So if I want to find angle AEB, which is this one, I already know this is 52. I already know this is 65 vertically opposite angles. I can just use angle sum of triangle. So straight away will get you this answer. Okay, for N-level question itself, this kind of question usually appear in paper 2, section B, and the questions are more or less straightforward because the second part will involve in sector and area. So for practice, I only give you just solving the angles itself only. But in the future, when I do more questions, it will be of paper 2 type where they need to combine it together with arc length, sector area, or even cosine rule. All right, so we will move on to the next few questions. Now, the next question, this triangle has sides of length 6 and 5 cm and the angle in between, right? So in order to use area of triangle, half AB side, C, angle in between, no need me to say. To find the length of the third side, use cosine rule. This one, I think most of you are familiar. Just see whether you can remember the formula or not. If you cannot remember a formula sheet have the formula. So need to know how to use. Okay, so this question, I shall not go through too much on it. Next. Oh, who's here? Oh, Enqi. Okay, next question. Okay, question number 7. Okay, this one is a very typical drawing graph question. The concepts are always very standard, repeated many times, but I think you've forgotten, some of you, right? There are a few lines over here, x plus y equals to 2 and x minus 3y equals to 6, right? Shown on the diagram. Now, first few things to take note. How do I know which line is which line? First one, I need to have a mental image of a general equation of a straight line. Y equals to mx plus c. Am I right? So if I have x plus y equals to 2, which is this equation, how do I know which line is it? First thing I check, make y the subject. Y equals to, if I shift it over, this is negative x plus 2. What does this tell me? The gradient is negative. Negative gradient, upward sloping or downward sloping? Downward sloping, right? So this is downwards. Next one, what is this? This is my y-intercept. So the y-intercept is cut the y-axis at the number 2. That means in this case, x plus y equals to 2 is this line over here. Okay, so when you interpret questions or you see diagram, do not just blindly do, you must also have some sense to know, be able to identify which line is which line. Next one, x minus 3y is equals to 6. This equation over here. Again, make my y the subject. Negative 3y equals to negative x plus 6. But I don't want to get negative 3y. I need to divide away negative 3y. So negative divided by negative will become 1 over 3 positive. Then this one will be negative 2. Right? This is my gradient, positive gradient. So this is upward sloping. Then the y-intercept is negative 2. Then the y-intercept here negative 2. So you can say that this one is the other line that's going upwards. So I will know a mental image of these two. Right? So find the gradient of this line. Now, any general equation is of the form y equals to mx plus c. So if I'm not able to, I know some students will want to plug in points, then y2 minus y1, x2 minus x1, right? So no need to do that. Just simply make y the subject. So x minus 3y equals to 6. So I keep 3y first. Okay, I don't like negative, so I multiply, try negative, I change the sign, divide okay, by 3. Now, a lot of students will do x minus 6 over 3 like that. When you do this, it's very difficult for you to identify the gradient and the y-intercept. So instead of doing this, we do it separately. We split up x over 3 and 6 over 3. And that gives me 1 over 3 units of x. Then 6 divided by 3, 2. So if that's the case, the y equals to mx plus c, n is my gradient, y-intercept is negative 2. So my gradient will be just 1/3. Okay, this one is a very simple concept and definitely will usually commonly tested. So must know how to do, all right? I will still repeat it in some of the other questions as well, as much as possible. Okay, next part, this one is a application just to test whether do you know what exactly is x equals to 0 over here. Okay, find the area of the region bounded by the lines. If we do it wrongly, we may think that, oh, this one over here is my triangle. There are many different triangles. I can have this triangle, I can have this triangle. How do I know which is the correct triangle? That depends on whether do you know how to read this equation or not. Okay, so this is x equals to 0. X equals to 0, it means what? X equals 0 means it cut the x-axis. It is a vertical line. Okay, it cut the x-axis. So if I were to have a line like that, this one is x equals to 4. It cut the x-axis at the number 4. So this is called x equals to 4, something like that. But now where is x equals to 0? X equals 0 will actually be the cut the x-axis at the number 0, which is actually my y-axis. So if I have just now the blue color line, the upward sloping line, and then now bounded by the y-axis, that means it's actually looking at the area of this triangle over here. Okay, so I'm looking at the area of this triangle. Area of triangle half times base times perpendicular height. So we try to find the base, which is this will be 4 units over here. Then the perpendicular height from here all the way to the tip of the triangle, that will be 3 units, right? It's not cm, it's units. And please don't count the squares. Read the units on the axis, because sometimes 1 square may represent 2 units, right? So you don't just count the squares, must count the units that's available, right? So if it's 1 square 2 units, then this one will not be 4, this one will become 8 units already. So the number will greatly change, right? So area of triangle, half times base times height. Okay, is this question okay? Can then I move on to the next question already? Y'all got anything need to ask? Okay, don't have, then I'll move on next one. Next question, this one, making this the subject. Okay, again, this actually just, the question just wants you to make something the subject, but they try to apply into a story, into something real life practical situation, but actually it's just changing subject variable. So how do we do this kind of question? A few things to take note. Number 1, opposite of square root is to square both sides. Okay, if you have a square on its own and you want to take square root on your own, you need to do plus or minus square root. There will be 2 answers. All right. Then the rest, if you have fraction, you try to cross multiply, get rid of the denominator. Okay, these are some of the basic skills. Then you have other skills that involves group, factorize, divide, grouping, factorize to get the subject, then divide away. But maybe I won't give you this kind of question yet. You'll come up probably later in our practices in class, right? GFD. Okay, so in this one, the first one, I'm not going to go through, just finding answers. Now, how to express W in terms of D and S. Okay, first one, let's check. There are a few things down here. W is trapped inside my bracket. Before I do anything, I must rescue W out first, or try to get rid of the things that are outside first. So my outermost enemy is actually my square root sign. In order to get rid of the square root, I need to square both sides. Just to take note, this is just S on its own, so you square it. If I have, for example, S over 2, you want to square it, you must square both the numerator and the denominator. because the number will change. All right, so if you have a fraction, you must remember to square both the numerator and the denominator. But in this case, don't have, we just have this. Then next thing, second part, there's always a fraction. If there's fraction, I will try to deal with fractions first. I don't like denominators, so I'll multiply away the denominator, or you can simply do cross multiplication also can. Then down here, there are two different methods. Either I can divide away 3D or I can expand it up. So the first method is I don't want the 3D, I divide away by 3D. Left with W minus D. I don't want minus D, I shift it over, it becomes plus D. Rewrite W as the subject. Okay, or secondly, because some of you might be too used to doing expansion, you might want to expand it out, no problem. If I expand out, then it will be 3DW minus 3D. This is the only term with W. I'm going to shift all the other terms without W to the other side. So this is minus, so here will become plus. This is 3D times W. I just want W. I don't want 3D, so I have to divide by 3D. Okay, actually the two answers are the same. If I'll take 8s squared over 3D plus 3D squared over 3D, cancel away, I'm left with just D on its own as well. Okay, some of you may change sides, different sides. You may get negative sign, doesn't matter as long as your method procedure is correct. Or if not sure, you can just take picture and show me your answer. I can double check your answers for you. Okay, any problem with this question? Okay, N-level sure will have one question on changing subject variable, but this question is considered relatively more difficult already because it combines a few skills together in one question. Right? Okay, section B. Okay, section B, the first one over here, just to calculate the number. Okay, first one, just calculate the number. Now you notice I did not leave it in terms of decimal places, because if it's in decimal places, I probably need to round it off to 3 sig fig, may not be the exact value. Since my calculator is able to give me in terms of fraction, so fraction is always exact value as much as possible. So in this case, I chose to leave it in fraction. I do not know whether N-level will accept. I think maybe they will accept, like if you round it off to properly to 3 sig fig, I think maybe they should accept, should not be too strict, but just that my personal habit, I'll keep values as exact as possible. Now, next one for this question is just trying to make it difficult only, actually nothing much one. You just need to calculate this portion over here, tangent 12 plus cosine 46. Key into your calculator. For me, I copy as many decimal place as possible so that it be as accurate as possible. In fact, I key really, I just wrote it down. After I just shift inverse directly. Okay, then X is 1 dp, angle in degree 1 dp. Question say value. So you notice I did not put, I put my units here, I erase it away. So there's no units here, right? No degree, just the value for the X. Angle 1 decimal place. Okay, next one. Just now somebody said section B, right? Oh, question 1, A part 2. A part 2, this is the question. Yes. All right, so just calculate the value only, that's all. All right, sine inverse. Next one, the diagram here shows the framework. All right, this is just the application of Torcaso. I know many of you like to do sine rule. If you can get it correct, it's okay, no problem, can go ahead. All right, if not, then try not to make your working too complicated. It's just a few marks only, then it's not very worth it for very long working. Okay, angle, cosine of angle, ADB, to find angle ADB. ADB is over here. I have this side, which is 1.9, and this one over here, which is 2.2. This is 90 degree, therefore this is my hypotenuse. This side touches my angle, so it will be the adjacent. So twa, ka, and so that will be cosine. So cosine of angle is adjacent over hypotenuse. which is 1.9 over 2.2. Then you get our answer. Next, BC. So BC itself is this angle over here. Some of you may use sine rule. I don't know how you're going to use sine rule, but should be okay lah, huh? Right, so this angle is the side that's opposite to it, that matches. Then I want to find BC, which is my hypotenuse. So I use Picasso O and H sine. You want to use your sine rule, probably it look like sine 42 over 1.9. Sine 90 over H or something like that. Okay, the other way around also can. Just make sure you do your processes correctly. But it's very interesting. I don't know why they give 3 marks just for such a simple question. But yeah, I'll just get my answers. Okay, so do cross multiply. This one is divide. It's not multiply by sine 42, it's divide. Then it's in length and units. So this one, the units here is meters. So 3 sig fig for length, meters. Okay. Next question, part C. A vertical flagpole. So my intuitively first thing I draw a flagpole, draw a diagram. Vertical. Vertical means the flagpole and the ground will have 90 degrees. Okay. One is 18 meters. And the angle of elevation of the top of the flagpole, angle of elevation always means from bottom look up, bottom up. So the person must be somewhere at the bottom over here on the floor. Okay, on the ground, 25 meters from its base. So 25 meters from the base of the flagpole to the person. The angle of elevation look up. So in this case, Picasso, this is my opposite. This one touches my angle. So this adjacent, TOA, Picasso. Okay, O over A. Then inverse, you get your answer, degree 1 decimal place. Any questions? Next question over here. All right. Now, this question itself is actually cumulative frequency. For a few things to take note. First one, they already tell you 160 students took the examination. Now, just to be aware, sometimes the numbers here, the scales may give you, let's say 180. Then a lot of students will not read. You have to read the total to be where the curve stops. Okay, do not just read the axis and pick the largest number. They may give you extra numbers. All right, so if you're going to use like 180 or 200 based on the scale, then maybe it might be wrong. So you must always read, look at where the curve stops at. The curve stops at, and the question says it's 160 students. So in this case, this will be just the number 160. Okay, and what is this table? This table tells you the grade. What does this mean? It means between a few different grades itself, a different marking itself. All right, so for example, grade D is between 20 to 40. What do you mean by 20 to 40? Between 20, this axis is on marks. Between 20 marks to 40 marks, for example. Okay, if I want to know how many people score this grade, is this number in between the two tail ends? We need to do a subtraction to find the numbers in between the tail ends. Right, so that's what it actually tries to tell you for the different grades itself. Right, first one, find the median. Median 50% is the number 80, but this is not the answer. Remember, please draw the reading lines. Okay, please draw the reading lines. Show the examiner that you are reading the value from your graph. Because sometimes if you do not draw a line, but you accidentally write a wrong number, or you think the concept is there, they can still give you the marks. Let's say, for example, find interquartile range. It can still give you conceptual marks. Okay, but if you do not even draw any lines at all, you just take it as you plug the number from anywhere, and you got no marks. So please do draw your reading lines. Okay, so this number is 60. Interquartile range, upper quartile is 75% of 160. Some students like to do 75, I don't know, or 160 times 100. They do it the wrong way. So this number not correct. Don't know how y'all do it, but yeah, Okay, just be careful, don't count the wrong numbers. So 120, when it's 120, right? Read the value. Now the number might not be exactly a nice square, so you do need to count the units sometimes. Usually N level try to be kind, but not all the time, right? So this number is 70. Then lower quartile, 25%, which is the number 40, but 40 is not the answer. Draw your reading lines, read it from the graph. Okay, and then double check. 1, 2, 3, 4, 5. 5 squares to represent 10 units. So 5 square represent 10 units. 1 square will represent 2 units. So this one will be 48. All right, so this number will be 70 minus 48, 22 marks. All right, next question. Find the number of students who were awarded a C grade. C grade, what is a C grade? C grade is between 40 and 55 marks. Marks are marks. So what you need to do, go to your horizontal axis on marks, look for 40. Okay, I want to find the number of students. So I go to my frequency. Frequency tells me the number of people, right? So I go back and read this number. How do I know what is this number? Check. 1, 2, 3, 4, 5. 5 square represent 20 units. So 1 square represent 4 units. So got 24, 28. So this number is 28. This marks for C grade between 40 and 55. So look for the next mark, 55. 1, 2, 2.5. So 55, draw, read for the number of people. It may or may not be in between the squares. You make your own judgment. So for me, I thought it looked like it's exactly on the line. And this number is 60. So how many people score a C grade? The people in between here. So I need to take 60 minus 28. So 60 minus 28 give me 32 students awarded a C grade. Okay, so you should be able to read how to find these kind of values. Next part, now this one is on a pie chart. Okay, pie chart, how much is a pie chart? A pie chart full circle is 360 degrees. Then how many students are there in total? 160 students. Your full cumulative frequency graph, this one total number here, total students is 160. So 160 students represent 360 degrees. Calculate the angle of sector which represent the number of students who get a C grade. Okay, you cannot leave question blank. At least you use the, let's say you do this answer down here is a wrong answer. Doesn't matter. You use the wrong answer down here and you do the working, you can still get marks, maybe even full marks. It depends on the question. They may have error carried forward. Okay, sometimes if not, at least you get the method mark 1 mark. But if you don't do, then you got no number to continue, then you cannot get the marks at all. So 32 students, 32 out of 160 times 360 degrees. That gives you 72 degrees. Okay, usually the number should be quite a nice number. Okay, sometimes you might want to double check your calculations if the number is a little bit weird. Okay. Next question. Now, usually first part statistics comes together with probability question, right? So part B may be totally unrelated to the part A of the question strand, but they'll put it under section B, the same type of questions together. Okay, an ordinary unbiased die. Unbiased die means everything has a fair chance of occurring. So there are 6 numbers, everything got 1/6 of a chance. Right, now the question is, Sarah and Terry each threw a dice once, expressing your answer as a fraction in the lowest term. So they don't want decimal places, fraction. Sarah threw a 7. There's no 7 down here, right? So it's an impossible event. That's why probability is 0. Now, I was marking some papers. I saw 0/9 or something like that. This will not be given marks. 0 means 0. Just simplify the answers to 0. Or some of you may write 0/6 or something like that. No, this is not the final answer. You must write equals to 0. Then we'll accept the answer. Okay, they both threw a number 6, meaning I need Sarah to get a 6 and then a 6. 6 and 6. So and means we do a multiplication, 6 and 6. So to get a 6 is 1 out of 1, 2, 3, 4, 5, 6. So 1/6 times 1/6, which gives you 1/36. Okay. Next one, neither true and even number. This one you need to think a little bit. What do you mean by neither true and even number? So Sarah never throw even number. That means she must throw odd number. Terry never throw even number. That means Terry must also be odd number. So what's the only case? It must be odd and then odd. Odd, right? Out of a total of 6 numbers, how many are odd? 1, 2, 3. So 3 numbers, odd number and then odd numbers again. What Sarah throws does not affect what Terry throws. So you notice the denominator still stays at 6 and 3/6 times 3/6, which gives you simplest form 1/4. Right? Some students might write 9/36, then this one not the simplest form, will not be accepted as the answer. Okay. Next part, Sarah says, throw exactly 4 more than Terry. 4 more than Terry, huh? What do you mean by 4 more than Terry? That means I need to look at all these combinations. What can Sarah throw? Sarah must definitely throw a larger number. 4 more. So what combinations can I have? I can have Sarah to throw 6. Exactly 4 more. 6 minus 4, that will give me 2. So it's a combination 6, 2. That's one combination. Or, not and, or I can have this case, or next case, Sarah can throw a 5, right? Sarah can throw a 5. If Sarah throws a 5, that means 5 minus 1, Terry must throw a 1. So 5, 1. Okay, so this or this case, or means is to do addition. And what about the cases inside? This means this is 6 and 2. 1, there's only one number 6 out of 6 numbers, and then there's only one number 2 out of 6 numbers, plus the other one 1/6, only 1 5 and only 1 1. Okay, then simplifying the numbers in the simplest fraction, answer 1/18. Is this okay? So usually for this type of question in section B, they will have statistics together with a second part on probability, and the questions may not be related. So you just do that individually on your own. Before you choose, question for section B is 2 choose 1. Okay, 2 choose 1. Okay, just let me go back to next page. Question for section B is usually 2 choose 1. Okay, they can have in terms of the first question, either sine rule, cosine rule, bearing, one type of question. So the type of cases, you have trigo with bearing, one type. Okay, or you have circle properties with arc length, sector area. And sometimes the arc length sector area might need to do Torcaso or cosine rule. Okay, to find length or something like that, or perimeter. So this is actually the harder one. Okay, bearings is, but some of you, the bearing also do not know how to read the word problem. The third type is usually always statistics with probability. Okay, probability can come with many types. Probability can have calculate, mean, mode, median, standard deviation, compare, standard deviation, consistency, inequality, not inequality, interquartile range, or you can have the upper quartile, lower quartile, interquartile range, or box and whiskers plot. Then for the probability section, either it's like spinner, possibility table diagram, or a probability tree diagram. So it's usually mean these three types. While you study for paper 2, it's easier to pick the topics that you want to focus on, but you know your own areas and strength. Please study accordingly. Choose at least two. To be safe, there's two choose one question, but to be safe, you need to choose at least two to study for. In case the question strength is very difficult, then you can at least do the other one. You must at least study 2 out of these 3 combinations. Okay. That being said, which brings me to my last question. Last question is on graph. Now, in our times have changed, graph question can either come out in paper 1, or it can also come out in paper 2, section A, and they made it compulsory. Last time, graph is an optional question. It's inside, it's one of the 4 choices. But now they have taken out graph to be either compulsory in paper 1 or compulsory in paper 2, section A. So definitely you need to draw graph. There are a few main types of graph. While I still have a little bit of time, let me just explain what are the few main common shapes of graph that you will be drawing. First type, common shape, quadratic equation. This type usually can appear in paper 1, okay, where it's relatively easier to draw, or paper 2, real life applications, where they say, let's say I throw a ball, then the ball fly out. Okay, something like that. Then it's a real life application question. So if they come up quadratic equation, actually quadratic graph not a very good option because it will be a real life application question. You may not be too used to it. The next type of graph, the cubic graph, can look like that, can be like this, okay, can be the other way around as well. This type of cubic graph actually have a few main parts. They may not ask you to draw the whole graph. They will usually focus on areas that have the maximum and minimum point. They test you on whether do you know how to draw the maximum or minimum point. This question itself, later I will try to go through this one with you. There are some few tricks you need to take note that we'll try to test. Okay. The next type, I call it the Nike graph. Nike tick. What are these types? This is usually equations of the type that has something with 1 over x and another portion with an x. Okay, 1 over x is actually the graph that looks like that, right? Usually for a practical situation, they will always have x to be positive number. So they usually always choose this portion of the graph that is positive. Then the second portion, x, y equals to x is actually just an upward sloping straight line. When you add these two together, it actually forms a Nike tick, right? It looks like that. And your graph will usually have a turning point. They will definitely test you something to draw with a turning point, then you go up. And tendency students will try to draw a straight line over here. Please be careful, don't always draw a straight line. Sometimes it will become like a little bit of a curve this way, like like a spoon with a hook at the back. So if you want to insist on drawing a straight line, you'll find that my curve cannot fit in, because sometimes it's actually not a straight line. Sometimes it's actually a little part of a curve itself. So there are a few different types. These are the common 3 types of graph that is usually tested. One of the more rare types of graph is the exponential graph, which is relatively easy to draw. It looks like this. Just go up all the way. Okay, this type of exponential graph will come with questions involving population for bacteria, population of man, or whichever, because only populations and stuff like that will go in exponential form. Y equals to a to the power of x. The x is in the power. Okay, and this one will be real life situation. So for this view, this is real life. Usually, real life. Okay, and real life situation. For today's this graph over here, the cubic equation one, I tried to find a cubic equation where it's also in terms of a real life situation, and you notice there is no equation for you to calculate values at all. they will give you the values of the graph that you need to plot, and they will tell you this contains a certain units. So the x-axis is in terms of hours, right? Hours, meaning maybe I need to do conversion because I may need to know it, find the answer, the timing in minutes, seconds, or whichever. So for example, if I have a number 5.8 hour, how to find this? In hours and minute, that will be 5 hour. The 0.8 you need to multiply by 60. Please don't tell me 5 hour 8 minutes. Okay, this one will be 54 minutes. Right, so you must know when you have this kind of units, right, for practical situation, you must know how to do conversion of units. Okay, that's number one. So first part, when you have this kind. Secondly, this one, the y-axis is in terms of the temperature, y equals to something or whichever. Then, which brings us to a few important main concepts for this kind of graph. Practical situation, what can they ask me? They can ask me to find gradient. Okay, gradient of a graph is equals to y2 minus y1 over x2 minus x1. Am I right? Then we need to relate back to the question itself. They will not just ask me find what is the gradient. They will ask me to explain what it means, which I need to relate back to my question. Oh, the y is what unit? Y-axis is degrees Celsius. Over, what is my x units? X units is in terms of hours. What does this mean? This is degrees Celsius per hour. So this is actually a rate now in terms of degrees Celsius per hour. Okay, when we have positive gradient, it means at a rate, rate, we are talking about rate. So it means it's increasing, oh, how spell? It's at an increasing rate. When I have minus, a negative gradient, this means this is a decreasing rate. Why is these two words important? Because when we explain the question, we do not put plus or negative sign anymore. We use the words increasing or decreasing to describe and explain what the gradient represents. Is that okay? So this is one important concept. So a few important concepts for this kind of real life application. Number one, units. Check the units. What do we need? What do they mean? Do I have conversion? All right. Secondly, what does the gradient represent? Match in the units and try to interpret. Sometimes it's meters per second, meters per hour, or kilometer, or dollar per book, or things like that. So you need to read according to the question itself, right? Next part, using a scale of 1 cm to represent 1 hour. This one, please be careful of you drawing your units, and they give you a scale 0 to 9. Now, the newer versions of the graph, because this one, I took it from an older paper, right? So you still need to draw on graph paper. The newer versions will now start to give you the graph paper, the graph axis grid, right, is in black and white printed. No longer your green color graph paper. So you may find it even more difficult to see. And then the units itself may be also a bit difficult to read. Okay, but if it's in paper one, they may draw the axis for you, so you fill in the units accordingly, right? So please do check 1 cm to represent 1 hour, not 2 cm, 1 cm. Then a scale 2 cm to represent 1 degree Celsius. Okay, they said particularly draw from -2 to 4. So you must include these numbers in your axis. Okay, using your graph to find an estimate for the temperature when x equals to 55. Allow me to switch to my graph. So I've just drawn simply a graph over here. Okay, I try to put everything in the same page because nowadays they might give you the grid, then you write the answers below. So I just try to create a habit. Okay, before we start drawing this graph itself, there are a few things to take note. I myself is also find it very difficult drawing this graph because few things to take note when they test you on cubic graph or even the one with the Nike tick. Please do not assume that the minimum point is going to be your minimum point. If you do that, your graph will be a bit awkward. It'll be difficult to find a turning point. There is always somewhere else that is slightly lower or somewhere else that is slightly higher than the given point, than the points given. So you try to fit in your graph and make it smooth, and always remember the largest and the smallest value that they give you is not true. There is not always going to be the maximum or minimum, unless you can so happen fit the curve nicely and it really pass through, and that is really your minimum point, which is usually not that case. All right, so in this case, if you draw this graph, please take note, this is not a turning point. Those of you try to make this a turning point, you have a curve that looks like that, you'll be not smooth, very ugly. Okay. And then the next part of the question, when they ask you find the maximum and minimum value, you write that two numbers straight away is wrong one, usually most of the time. Okay. So we have our axis and our graph. This is the smooth graph being drawn. Try not to draw straight line. Try not to draw straight line over here. It's supposed to be a curve. If you draw a straight line later, you have a hard time finding gradient. Okay. Then when x equals to 5.5, so this is x equals to 5.5, I read my value. Okay, over here, so each square, count the number of squares. You have 10 squares to represent 1 unit, so 1 square is 0.1. So this number here will be 2.9 degrees Celsius. Okay, so I'll go back to my answer. So this one, 2.9 degrees Celsius. Okay, find the difference between the highest and lowest temperature. The track comes with the maximum and the minimum. Find the difference. So this one is estimate, using your graph to estimate. So my highest value from here, if you're going to put it as the number 3.5, then that's definitely going to be wrong. So use your own graph. If you know this already, when you see this kind of question, go back to your graph, quickly use the eraser, change, sheet a bit, change away, and make sure it's not 3.6, 3.5, maybe 3.6, 3.65, whatever number, just a little bit more, or 0.5 more also can. All right, so this number for me, I read it as 3.65. My minimum point, it was originally, I almost drew it at -2, but I decided to change it and make it a little bit lower. So it's slightly a little bit off. So it's -2.05 for me. Okay, but different people may have different answers. So if that's the case, I found my answer over here. Subtract away the two values, you get your answers. Okay. Next part of the question, now comes the application question. How long in hours and minutes? See, they ask you to do conversion, right? And the temperature was above 2 degrees Celsius. 2 degrees Celsius. Degrees Celsius is my y-axis, right? So let me go back to my graph. Look for 2 degrees Celsius above. Okay, let me take out my ruler. Okay, above 2 degrees Celsius. Where is the portion of the graph that is above the 2 degrees Celsius? Okay, this is the portion that is above 2 degrees Celsius. But what do they want to find? They don't want to find this portion. They want to find the timing. How do I find the timing? Timing is in the x-axis. That means I must read my x value, and then where is above, until this point, this x value. Different people will have different x value. 5, 2 is given, so this point definitely starting point is the same, but the ending point here, it depends on how you draw your graph. So different people will have different answers. Try not to match your answer to my graph, because my answer also may not be accurate. Okay, I also do it by drawing itself, by estimation. So now, what is this duration? How long? Okay, read the question very carefully. They want how long. They did not say from what time to what time. If the question is from what time to what time, that will be from 5 minutes to 8 point, from 5 hours to 5th hour to the 8.3 hours, something like that. But they want how long? They want duration. Another word, they also can ask you duration. So duration also means how long. Okay, so that means we need to do subtraction. So in this case, I need to subtract. My answer is 8.3. So your answer may be different from me. Minus 5.5, I got a 3.3 hours. But they want hour and minutes. It is not 3 hour and 3 minutes. So the 0.3 is 0.3 times 60 to convert it to minutes. So it's 3 hour, 18 minutes. All right. Then, so I got my answer already, the duration over here. Okay. Next part. Okay, let me erase away this one for a bit because I need to use it for the next part. Okay. Next part of the question. By drawing a tangent line, find the gradient of the curve at the point where x equals to 8. How to draw tangent? We haven't been practicing for a very long time already. You probably last drawn a graph maybe last year examination or something like that. Okay, but let's recall a little bit how to draw tangent line at the point x equals to 8. X equals to 8. Go all the way up. Look for the point. So this is my point. My usual recommendation, if the graph is not very steep or whichever, 2 squares or 1 square. So I will go 2 squares to the left, 2 squares to the right. Only these two stays the same. The height may be different, right? So then I go all the way up to touch the curve and then all the way down to touch the curve. Right? This portion over here and this portion over here may not be the same length. Some of you thought everything must be the same. Then your answer will always be the same. Not correct, okay? So the height itself, the vertical direction may not be of the same length. Then next, what do? We take our ruler, okay? I put my pen at the point X itself. I use these 2 dots that I have. Okay, try to zoom in a bit more. Okay, I use these 2 dots that I have as a guide for me to decide my slope. Then I put my pen touching at the point over here and I slide up my ruler until it touches my point. Okay, then I have the ruler already, touches my point already. Then I draw my tangent line. Oops. Okay, sorry, my ruler. Yeah. Okay, I try to draw my tangent line, reduplicate my tangent line. Then I draw my tangent line. Okay, then I draw my tangent line. And tangent line, I try to draw it as long as possible. Okay, so that I got more values to look at. So I actually extended a very long line for my tangent line. Okay, so I try to look for points. To find gradient, must look for 2 points, right? Try to look for points that is easy for me to read. So in this case, I found it to be at a nice square at 7. And then this number here is 3.7. So that's for me. Okay, for you, maybe you can read elsewhere. Okay, some students say, can I use back this point to calculate my gradient? Technically speaking, I cannot say no because it lies on your tangent line, right? Okay, but usually I try not to because the points around the area can be quite, how should I say? It's a little bit pointless that I always use back the same point to calculate. Okay, I try to estimate from a range away from my points, but I'm not saying that you cannot do that. You can do that. Okay, so for me, I found another point over here. Then gradient is y2 minus y1 over x2 minus x1. There are still people who do the values wrongly, who calculate who write the x and y values wrongly. I don't know what to say. For this kind of question, now usually we always say gradient or whatever should be exact in fraction, right? But for this kind of practical situation question or this kind of question itself, do not put it in fraction form. Always give to 3 significant figures. Okay, always give to 3 significant figures in decimal place. The teacher will give the answer of plus minus a certain small range to within the reasonable answers. But if let's say your answer for gradient is not accurate, you must at least minimally draw the line and show the working to get the concept marks, the method mark. And why is it still important to find the answer? Because you need to answer the next part of the question. Without the answer, you cannot answer the next part. And even if your answer is wrong, you use it to explain correctly. In the next part, they will still give you the answer mark for the second portion, error carry forward. Now, the second part of the question asks you, explain briefly what does this gradient represent? What does the gradient represent? Just now I mentioned gradient y2 minus y1 over x2 minus x1. The y2 is, the y-axis is degrees Celsius, all right, degrees Celsius. The horizontal x-axis is hour. So this is actually degrees Celsius per hour. So it means this is actually a rate. Okay, a rate, for example, like speed, like cost, like rate of cost per book, things like that. But let's not make it too difficult. Just say that this is a rate of what over what. And then we know that this number here is a negative gradient, negative 1.29. Negative means this is going to be a decreasing rate. Okay. So the gradient indicates that, or for me, I write it as the temperature is dropping, or by right, I should write decreasing, alamat. Okay, actually dropping and decreasing is something similar, but I don't know why. I think I should write decreasing. Okay, is decreasing at a rate of 1.29 degrees Celsius per hour. You notice I never put any more sign down here, no more negative sign, because I explained it saying that this is the decreasing rate already, dropping rate. And then make sure you include the units, degrees Celsius per hour, either write it in terms of units or write it in terms of words itself. You must state the units. Okay, so this is how you explain this kind of question. Okay. Any other questions? With that, I come to end of this part, end of this paper already. We complete before time. Any particular questions you need me to repeat again? No? Yes, yes, no, no. Hello? Hello?
No, nothing.
No questions already. Oh, okay. Okay, then I end off today's lesson already. Oh yeah, somebody put I'm sorry. Okay, so if you have questions you want, you can step back and ask me. I'll go through with you. If not, then you can leave already. Thank you very much. Bye-bye.
Bye, Joe.
Bye-bye.
Bye-bye.
Bye, Joe.
Bye-bye.
Bye. I go already.